Okay, so now that we've calculated our p-values and our effect sizes, how should we use this information? What does it tell us about the utility of our model? So in this case, 2 of our test statistics seemed to fit relatively well. They had p-values that were fairly close to 0.5 and had small effect sizes. But 2 of our test statistics seemed to indicate relatively poor fit. They either had very small or very large p-values, and both of those had fairly large effect sizes. And so these 2 values do indicate a discrepancy between the assumptions of our model and the data we've actually collected, the empirical data from our population. So should we be concerned? And I think the answer really comes down to what we want to use the model for and what we want to understand about our population. If we're simply interested in understanding the average value of the trait in our population, then our model is doing just fine. But if we wanted to say predict the trait value of any given individual in our population, we might not actually do very well. So we're going to tend to overpredict individuals with intermediate values, and we're going to tend to underpredict individuals with extreme trait values. And from a process perspective, if we're interested, say, in understanding something like the strength of stabilizing selection, our model might not work very well. So our single normal assumption might suggest that our population actually has quite a lot of trait variation between individuals, when in fact much of that variation is between the different sexes. And within each sex, there's actually a more limited amount of variation. So really the answer about what we want to, about how concerned we should be about poor fit really comes down to what we want to know. And I think this is a more general conclusion that applies to the phylogenetic case as well. What we want to use our phylogenetic models for is going to determine how we should go about assessing model fit.